Yeah. Good evening, everyone. For joining us, let's start off. So last class we did this, the differentiation of a vector. Others comes on. So today we will see more of an application thing. Maxima and minima. Who else is there? Others comes on. Mehan, Molika, Ritu, Ronak comes on. Great. So maxima and minima. So this is one more important concept in physics, right? Later on we will see a lot of stuff, a lot of times we like to find the maximum value of a certain function. It could be anything: the maximum distance traveled, the maximum force in a string, the maximum elongation. So you'll keep hearing these kind of words, or the find the minimum speed required to escape the certain field. So we want to know what is the maximum and the minimum value of a function. But technically speaking, what's the maxima? Maxima is simply a maximum value in a local region. Basically peaks. A minima is simply minimum value in a local region. Values. And now don't get confused. Maximum does not mean it is a maximum value. Minimum does not mean a minimum value. That is another situation there. So let me give an example. Maxima and minima is simply a peaks and valleys. So if you have a function like this, if you look at these points here, 1, 2, 3, in the local region, they are the maximum values. 4, 5. If I just put one more like this, and 6. So if you see here, 1, 2, 3 are maxima points. So basically, when you stand at a maxima, right, on the left hand side, on the right hand side, the curve is going down on both the sides. Such a thing is called a maxima, the peak. 4, 5, and 6 is called a minima. So when you stand at a minima, right, on the left hand side, right hand side, the function is increasing on both the sides. And if you notice something here, the value of 0.5, which is actually minima, is greater than value of 0.1, which is a maxima. So that's why I said maximum value in a local region. I never said it is an overall maxima. So maxima does not mean maximum, minima does not mean minimum. But in physics 11th and 12th, generally it works out. So just keep that in mind. Later on, I'll show you a part, where it doesn't work. Maxima does not mean it is maximum. Or not maximum and minimum values. But generally in physics, it works out. For our curriculum, basically for our current curriculum. We will not go too deep into that. That'll become more of a max oriented. Local region meaning in this surrounding, right? So in this surrounding, there is a maximum. In this surrounding, this is the minimum. In this surrounding, this is the maximum. So local region meaning a small area. Don't go too beyond. If you take the entire thing, this is not a local region. This is the overall region. Na? So this is a local region. Okay. Yeah. People whose camps are not on, I'm removing you from the classroom. I already kicked out 3 people right now. If there is an issue with your cam, you have to leave me a message. That too, ideally before the class. Monica, you need to adjust your cam. I can't see you completely. Have a look at this. All clear with this? Yeah, Venkatesh, Shreyash, if you don't keep your cams on, I'll be removing you from the classroom. So you should mention that, right? You should tell me, or else I'll assume you're sleeping in the class. Physics people are very suspicious. Okay, all clear with this? So, great. So how do we find this maximum and minimum exactly? Let's find for each one. So for maxima, if you look at the function, it's a peak. If you observe this, look at this point here. This is the tangent. At this point, this is the tangent. At this point, this is the tangent. This is the tangent, and this is the tangent. So if you look at the slope here, slope is positive, less positive, 0, negative, more negative. So basically this thing is slope. The curve is actually initially more steep, then it becomes flat, and then it goes down. So whenever you're going over a maxima, we observe the slope. We observe as we go from left to right. Slope decreases. And at the highest point, the slope at the peak is 0. So that's a pretty important idea there. Basically, whenever you're taking a turn for a moment, see, when you're going from +5 to -5, you have to touch 0 at least once. Without touching 0, you can't make a turn. So the turning point will always have a 0 slope. And here, if you see the change in slope, that is a final minus initial, is always negative. So we get 2 conditions here. So whenever you want to find a maxima, don't worry, we'll do a lot of applications on this. Condition 1, slope at that point, which is dy by dx. Remember, that's the slope should be 0. That is condition 1. Condition 2, the rate of change of slope. You said na slope is change in slope is negative. The rate of change of slope should be negative. But what is slope? D by dx of slope is dy by dx. That means the double differential is negative. So these are the 2 conditions. So at a point, if the slope is 0 and the rate of change of slope or the double differential is less than 0, that point is a maximum. Just note it down. I know you understood it is a little vague. We have to do a few problems, then you get it. Again, I'm telling you, physics, right? Most people have this misconception, I'm not getting a problem because my theory is bad. In reality, physics may the theory is actually very less. There are only 5 to 6 concepts in a chapter. When you start solving problems and when you get stuck and when you fight with the problem, your theory actually becomes better. So if you have a misconception like that, right? Just because my theory is bad, my problems are not coming, it is not that. You should know a basic theory, start the problems, you will learn some more, then your theory improves, then your problems improve. It's a cycle. School mein hota hai, like, you just mug up everything and go to the exam. Any doubts on this thing, please ask. Malika, you need to adjust your cam. Rehan, you also need to adjust your cam. Venkatesh, I can't see your face completely. I need to see your face completely on the screen, everyone, so that we can find out if someone is eating secretly ice creams or cakes. So, yeah. Palaksh, you also need to adjust your cam. Your cam looks like as if you're living in some foggy area. Do something about it. Clear with this maxima? Any doubts? Great. Same way, if you look at minima. Hello, you said something. I couldn't hear you, Aryan. Aryan? You said something? Mic's not working. You can type to the co-host here. But do make sure your cams and mics are proper, everyone. You need to talk. When you have a doubt, you need to speak out. Could you go by? Check it out, check it out. You can put on the main points and you'll be sending videos. You can notice. I'll send you a sheet on differentiation today. This week we have an exam on vectors, advanced paper. Means there'll be single choice questions, more than one choice questions, integers, paragraph, matrix matching, all that combination का something will be there. Single choice will be +4 -1. Anyway, I'll put it in the group before posting. More than one choice, you get partial markings. Partial marking meaning there are 4 options, A, B, C, D. Let's say A, B, and C are right answers. 1 mark for right answer. If you mark all 3, you'll get 4 marks. But if you mark A, B, and you get a -1. Getting the marking scheme? This is the actual marking scheme in advance. Partial marking. So if you mark only the right answers, but not all the right answers, you get 1 mark for each right answer. If you mark even one wrong answer, everything will become -1. So if there are 3 right answers, A, B, C, D, if you just mark A, you get 1 mark. If you mark B, you get 1 more mark. If you mark C, you get total 4 marks. But if you mark D, you're 1. That way. I think this time we don't have matrix matching. No, we don't have matrix matching. We have integers, more than one choice, paragraph, and integers. So answers can be a number 0 to between 9. 0 to 100. Any integers, it will be any number integer. 99, 77. You'll get an option there to type an answer. So you'll get used to it. Don't worry. Actually, I can send you a sample paper of advance also. Should I do that? I'll send you one sample. See how it works. I think that will be good. I'll do that today. So I know for most of you, the last time was the first exam. So it's okay. Don't worry too much about the marks right now, but you keep studying. The main thing is the process. The work will slowly build up. The work will increase. Booklets will be dispatched by this month and you'll be getting it. Then for printing, it'll take time. So what about a minima here? You can solve your classes the booklet anyways. Books are fine. You get a lot of books. So here, if you see the slope is negative, big negative, less negative, 0, then the slope becomes positive and the slope is more positive. The line is becoming more steep. Voice is cracking. Is my voice clear, everyone, or cracking?
It's cracking.
It's cracking.
Yes, sir, it's cracking.
It was cracking like when you were talking about that paper.
I think it doesn't like about the paper. Is it better now?
Yes, sir.
Everyone better? Yeah. So let me know if it's cracking, not audible. You should immediately alert me. You can just unmute and tell me. That's fine. So here, what is happening here? So as we go from left to right, first of all, the slope increases. The slope at the minima is 0. So condition 1, voice is cracking. I know something happened, but I don't know why the signal is bad. Just give me a minute. Let me see. Signal is bad, right, today? Is it still cracking? Yeah. Only 2 points of signal. That is weird. It used to be full every time. Okay, let's see. Is there something wrong today? So nothing. I was just saying condition 1. There is a lag actually. What the hell? This Wi-Fi also now. Just give me a minute. Let me change the position. This is better. So condition 1. The slope dy by dx is equal to 0. Condition 2. The rate of change of slope is increasing. It is positive. So the double differential d square y by dx square should be greater than 0. These are the two conditions. So here slope is always increasing.
So the second one is called the second order derivative, right?
Yeah, it's a second differential.
So
Second order derivative.
basically, if the second order derivative is also equal to 0, then the function is basically a straight line, right? Like a horizontal straight line.
We do have something like this. We'll not get into it. That you will find some weird functions like this. You have a function So this function, right, if you see on the right hand side increases, left hand increases. Here both are 0. So we do have functions like this. We will not do them in physics. Max will teach you.
Okay.
So that if you see that line which I draw, right, double differential is 0, first differential is 0, but it's not a straight line.
Oh yeah.
Straight line, both are definitely 0, but it need not be straight line every time. Check, everyone have a look at this. Am I still lagging or better? Better. It's weird actually, something happened today. Okay. Next one, go ahead. Now let's see some applications of this. How to actually find maximum minimum. We'll start with something simple and then we'll go for applications. Turning the page. Let's start with an easy one. We have a function y is equal to x square minus 3x plus 2. I'll show you one, then I'll ask you one more. You can then see. Let's take a better one. Y is equal to x cubed by 3 minus 3x square by 2 plus 2x plus 1. So this is some kind of a function. The question is find the maximum and the minimum value of the function. Find max or minimum value of y. Okay. Now listen how to do. I'll show you one. Step 1. Differentiate dy by dx should be x square minus 3x plus 2 equal to 0. We get x is equal to 1 or 2. We got two roots. Now we don't know which one is maximum, which one is minimum in this. There are two things here. So we don't know which one is maximum, which one is minimum. Which gives max or minimum. That is when the second condition will come. Step 2, you have to differentiate double differential. D square y by dx square, that is dy dx of dy by dx. So basically this function, I have to differentiate it again. So that will be dy dx of x square minus 3x plus 2. So this will be 2x minus 3. Now, how do you check? So we got two roots, right? At x is equal to 1, the double differential dy square by dx square will be 2 into 1 minus 3, which is minus 1 less than 0. So if the function is less than 0, what is this? This is a maxima. Because see, we saw here for a maxima, the second differential is negative. So differentiate and put that values which you got in the first differential. Listen carefully. I'll give you time to think about this. Because if you got this idea, it is easy to solve after this. D square y by dx square will be 2 into 2 minus 3. This is plus 1 greater than 0. This is a minima. So what is the meaning of this? The meaning of this is at x is equal to 1, y is maximum. X is equal to 1 is not maximum value. When you keep x is equal to 1, y ka value will be maximum. So when you substitute here, how much you get? 1 by 3 minus 3 by 2 plus 2 plus 1. This is your maximum value of y. At x is equal to 2, y ka value is minimum. And the minimum value of y will put x is equal to 2 in the function. Cube by 3 minus 3 into 2 square by 2 plus 2 into 2 plus 1. You have to simplify that. Just have a look at the steps. Yeah, signal is gone again. There is some problem with your Better. Today something happened actually. Normally I use this Jioka SIM. Today the signal is pretty bad. Weird. But have a look at the steps, everyone. I'll give you one more like this. You try. But did you get the steps? So what is the step 1? Differentiate equal to 0. Step 2, double differentiate. Whatever function you get, put the values of 1 and 2. If you get less than 0, means that 1 is at 1 you will get maximum. If you get greater than 0, at 2 you will get maximum. Now understand the difference. X is equal to 1, X is equal to 2 is not maximum value and minimum value. You have to put that X is equal to 1 back in the Y function, then you get a minimum value. Is this clear, everyone? Anyone didn't get any particular step? Please ask.
Sir, this will be the maximum and the minimum value for which bracket?
For the Y ka value, right?
So this is not the global maximum or minimum, right? Because
that's what I'm saying. We will not deal with that right now, Rona. We don't, in physics, we don't deal it. We just take it as maximum and minimum. Actually,
Okay.
luckily for this function, right, this is a global maximum and global minimum. The function could have been actually like, what, for example, say, Ronak, if it is like this, now you tell me what is the maximum value and what is the minimum value of this function?
it's infinity, the graph goes.
Actually, see, everyone, if you see this, there is no maximum, there is no minimum for this. Because maximum is plus infinity, minimum is minus infinity. But this function, the technique which I taught you, will give you this is maximum and this is minimum. I hope you're getting the difference. So what we are doing for physics sake is like we are keeping it simple. In real life, it is pretty messed up. You won't get the maximum and the minimum values. Like I said, we are not a max class. Those values of X are called, no, Aditya. Those values of, the values are called, maximum and minimum occur at X is equal to 1 and X is equal to 2. The maximum and the minimum value are this one. This is the maximum value. This is the minimum value of Y. Okay? I was just lazy to calculate. I didn't get it, but you can add it. How much is this if you add it? 3 minus 3 by 2, 3 by 2 plus 1 by 3, 11 by 6. That's your maximum value. Okay? Next one. Now you guys try. Y is equal to x cube by 3 minus 5x square by 2 plus 6x plus 1. Find maximum and minimum value of Y. Get it? Physics no one will ask you like this. Questions won't come like this. I'll show you how they'll come. We will do next applications. But you should know, if you can do this, means you know how to calculate at least. Like I said, physics the headache is always how do you convert a verbal problem into calculus? That's always the headache. Try this. 2 and 12. Okay. Find the maximum and the minimum value of Y. 2 and 12, they look such good numbers, right? Maxima is at 2 and minima is at 3. But I didn't ask you that. I asked you what is the maximum and what is the minimum. So you have to put 2 and 3 in the Y value and get the values again. Try. One more minute, everyone. Differentiate equal to 0. You'll get 2 and 3. Double differentiate, then put 2 and 3. See who is giving negative, who is giving positive. I don't care exactly what number is that. I just want whether it is positive or negative. And then put it back in that. I think Ronak got 5.66 and 5.5.
It is not coming as 2 and 3. It is coming irrational numbers. Yes.
If I differentiate this, what is dy by dx? X square
minus 10.
minus 5x plus 6, na? वो 2 cancel नहीं किया क्या हजरत? So I give you good numbers only, right? So we get x is equal to 2 and 3. So one of them is maximum, one of them is minimum. Then double differentiate. That will be 2x minus 5. Six and 17 by 2. That looks right. And then substitute at x is equal to 2. D square by dx square will be how much? Minus 1, which is less than 0. So this is actually a maxima. So y at x is equal to, so y max will be, substitute that, 2 cube by 3 minus 5 into 2 square by 2 plus 6 into 2 plus 1. How much is this? 8 by 3 minus 10 plus 13, 17 by 3. Yeah,
Yes, sir.
that is the maximum. Then d square y by dx square, that will be at x is equal to 3. This guy will be plus 1, greater than 0. So this is a minimum. So y minimum is 3 cube. 27 by 3 minus 5 into 3 square by 2 plus 18 plus 1. 9, 45 by 2 is 22.5 plus 19. How much is this? 3.5, 6.5? Am I right? Or 5.5? 5.5. All got that? So 5.5 is minimum and 17 by 3 is maximum. Check. Any doubts on this? Malika, got this? Ritu? Ritu, your camera is totally blank, right? It became dark. Palaksh, Venkatesh, clear. Abhinav, Rehan,
Yes.
Shreyash,
Yes,
clear?
sir.
No? Great. Let's see one more. Turn the page. Suppose if you have y is equal to x plus 1 by x, find maximum and minimum value of y and plot the graph. Let's get this thing. This will be interesting. Get this one, everyone. Y is equal to x plus 1 by x. Find the maximum and the minimum value. Any answers? See. So if I differentiate this dy by dx, this will be 1 minus 1 by x square. I'm sure by now you must have got used to this level of differentiation. Equate to 0. You end up with x is equal to plus or minus 1. There are two roots. Now if you do double differential, that will be 2 by x cube. X power minus 2 ka differential, no? Right? This differential you have to do. 1 guy is 0. X power minus 2 is minus 2, x power minus 3. So that will come down to 2 by x cube. Set x is equal to 1. Please ask me if you're confused there. I skipped a step. I'm not doing calculations. This will be 2, which is greater than 0. So this is actually a minima. So y minima will be put x is equal to 1, 2. Similarly, d square y by dx square 2 by x cube at x is equal to minus 1. D square y by dx square is minus 2, which is less than 0. So this is actually maxima. This is minus 2. Did you see something weird? If you actually plot the graph, y versus x graph, you know how this graph looks? This is one more way. Listen to this thing, how to plot graphs in case you're confused. If I make x is equal to 0, what will happen? This will be 0, but this number will become infinity. 1 by x will become infinity, right? Similarly, if x is infinity, if x is a very big number, this will be very big and this will become 0. That means when x is 0, the graph is actually like this. You're getting how the graph is? When you get very close to origin, you'll go to infinity. When you go very far also, you'll go to infinity. And look at the irony of the situation. This is your minima. This is x is equal to 1. And you're getting this is a minima, whose value is plus 2. This is x is equal to minus 1. This is maxima. And this value is minus 2. So this is what I was saying. Maximum need not be maximum. Minimum need not be minimum. Are you getting the catch? But luckily in physics, you won't have this problem. At least the type of problems that we will encounter in physics applications, we won't have this problem. So it is just for your sake, I'm just trying to show you one. So be careful. Maximum need not be maximum, minimum need not be minimum. So this thing, right, at x0, you'll go to infinity, at x infinity also you'll go to infinity. Y become pretty large. Check, ask me if you're confused anywhere. Clear with this? Let's see some applications. Any doubts on this? Now, exam they won't ask this way. The question will be framed in a different way. Let's see how they'll ask applications. We'll start with an easy one and then we'll take more varieties. In an orchard, there are 50 apple trees. So you have a big orchard and you have 50 apple trees. each tree produces 800 apples per year. So that is fine. Each tree produces 800 apples. So then someone told you, Arey, why don't you plant more trees? You know, you have space. So you said, yeah, let's try planting more trees. But generally what happens, right? Whenever you plant more trees in that same area, there is a fight for resources. So for every new apple tree, the production decreases by 10 apples per tree. So if you put one more extra plant, all the trees will produce 10 apples less. Decreases by 10 apples per tree. So the question is, now just imagine if you plant one tree, what will happen? All the trees will produce 10 apples less. But this one new tree will produce 790 apples now. So it's a profit, right? It is still a profit. Think of, if I just plant one tree, what will happen? There'll be 51 trees, right? And the previous 50 trees will produce 10 apples less. So you will lose 500 apples. But this one extra tree will produce 790 apples. So you still made a profit. So the question is, how many more trees can be planted to maximize the production? How many more trees can be planted to maximize the production? Do you see? There is not a single mathematical statement in this. Now you have to create an equation from here. So they will not give you they will not give an equation. You have to create an equation and then you have to use maximum minimum. Try. I'll give you 2 minutes.
Sir, I didn't understand the question.
We have a big orchard tree. Okay, you don't like apples. So in a mango orchard, there are 50 mango trees. Each tree is giving you 800 mangoes. For every extra plant that you plant, the production will decrease by 10 apples per tree. Matlab, if you plant one tree na Mayuka, initially kitna produce kar rahe? 800 apples, no? It will produce 790. If you plant 2 trees, it will produce 780. But by planting new trees, you're getting extra apples also, no? So how many plants should I plant so that I get maximum number of apples? If I plant a lot of trees, all the plants will stop producing, isn't it? For example, Mike, if I plant, let's say 50 trees, all the trees will produce 300 apples only, isn't it? They will reduce the production by 500 apples per tree. Sure? Got the question?
Yes, sir.
Yeah. There, you don't like apples. I got it. Try. Anyone didn't get the question, please ask. This is what makes calculus a little weird. Applications. You give a verbal problem, you have to create into calculus. Try. 2 minutes. Just give it a try. Just give it. I'll get some water and come. Someone got an answer. Adrit, Rehan, Ronak. Yeah, you all got it right. Aditya, that is too big, right? Too big it is. Yeah, let me help you. So first of all, we have to create an equation out of this. Let the new trees be X. Let the production be P. So what is the production? Number of trees into apples per tree. So how many number of trees are there? 50 are initially plus X. What is the production? Normally you produce 800 apples. For every one tree, your production decreases by X, by 10. So it is 10X. So we have created a quadratic, which is 40,000 minus 800x minus 500x minus 10x square. So P is 40,000 300x minus 10x square. dP by dx will be 0 plus into x equal to 0. X is equal to 15. You can check for double differential, but this is one advantage in physics. Since I asked you maxima and I got only one answer, it should be maximum, right? If there are two things, you will be confused. Maxima or minimum. This is one answer. If I ask you maximum, it is maximum. That's it. Question is done. X is equal to 15. So you have to plant 15 trees to get maximum production. What is the maximum production? Now that I didn't ask you. Maximum production, substitute 15 there. 50 plus 15 by 80 minus 150. That will be 65, 42,250. Yep. That is the maximum thing. If you actually plot this graph, I'll turn the page. If you actually plot this, you will learn this in maths later on. It's a parabola actually. The production of apples will actually kind of look like this. At x is equal to 15, the value will peak. This is the maximum. Initially, it was 40,000. This is 42,250. Once you cross 15, right, the production will actually start dropping again. Have a look at this. Did you observe one thing? Isn't the max part easy? Once you got the equation, question is easy. The headache is to get the equation. Have a look at this. Let's see one more like this. Any doubts on this? Anyone not clear with any particular step here? Clear? Next one. Turn in the page. Next one. Should I turn the page? Tell me if you're writing or something. Yasha, clear, na? Clear, right? Yeah. Great. 17th one. Top view. You're seeing this from a drone or something. Top view. So we got a lake here. We got a point A here. We got a point B here. We got a point C here. This is 10 kilometers, the width of the lake. PC is also 10 kilometers. And here we have a man here. So velocity of the man when he's swimming, it is 3 kilometers per hour. He can swim in the water with 3 kilometers per hour. But when he's running on the ground, he can run a little faster. On the ground, his speed is 5 kilometers per hour. Okay, now he is going to A to C. Now, how can he go from A to C? C. One, he can directly swim and go, but that will take more time because he has to swim only. Or you could have gone B and start running there, because when you're running on the ground, it is faster, isn't it? Or you can do somewhere in the middle and you can go like this. So there are infinite ways you can do this. Is this making sense? So the question is, find the minimum time taken for the man to go from A to C. Find the minimum time taken by the man. He can go any way he wants from A to C. He can swim, he can go to B and run, or he can go to middle and run. He can do anything. What is the minimum time?
The R, A, and B collinear.
And we are on the same line.
Okay.
Sir, just a doubt. When he swims from A to B, doesn't he automatically drift and go to C?
Lake keh rahe.
Oh,
Lake,
oh,
it's
okay,
not a
okay.
river.
Okay.
It's not a river. It's not drifting. It's a lake, people. Water is not moving. Water is a. I hope the question was clear. This is what you expect. No interest in actually the differentiation and maximum minimum. Questions will be formed like this. Find the minimum time taken for the man to go from A to C. Try. I'll give you 3-4 minutes. It's a good one. Any answers? Like I said, you have to form an equation. Creating that equation is a headache. If you got that, then life is easy. Keep this question in mind. I'll teach you this again in optics. Lightway, I'll teach you a way to do this. The man should go in the direction, the path of a light ray. But we will see this later on. Anyone confused with the question, please ask. Try. I'll give you another minute and a half. It's important you try. Don't waste your time writing the question and I'll focus. You'll get the notes. Focus on solving. Use the time to think. Any answers? Let me give you the steps at least. How do you start the problem? This is point A. This is B, this is C. So let the man go from here to here and here. We don't know where is he going. So let this distance be X. You're getting it? So that X ka symbol will take care of it. Suppose if he's going from A to B and B to C, X will come 0. If he's going from A to C directly, X will come 10. So you don't worry what is, how it is going. You always assume an intermediate case. And this will be 10 minus X. And this is 10. So we are assuming the man is going from A to, let's call this point D. And then from D to C is running on the ground. Now, what will be the time taken here? The time T will be AD by speed 3 kilometers per hour when he's running in the water, DC by 5 kilometers per hour when he's running on the ground. What is AD? Root over 100 plus X square by 3. What is DC? 10 minus X by 5. There, you got your equation. So you got the time in terms of X. So you want to minimize the time. So what to do? So there you got the equation. dt by dx is 0. Get it? This is important. This is how you frame the question. Let the man go till some point. Let that be X. So for different values of X, you get different times. I hope everyone agrees with that statement. For different values of X, you will get different times. Among all that X, there is one thing which will give you minimum. So dt by dx is 0. But Ronak, question find minimum time, not X. Question is find the minimum time. So you have to find X and put it back in the equation. Try everyone, I'll give you a minute.
So,
All right.
so he can't swim directly because his velocity in water is lesser than his velocity on ground, right?
Come again. Your voice was breaking.
So the man can't swim directly from A to C because his velocity in water is less than his velocity
So
ground, right?
we don't know. No? There is a possibility running on the ground is better option than going directly in the water. We don't know. Suppose what you're saying happens now, then X should come out to be 10 automatically. Let the max give you that. You don't make an assumption how he's going. So differentiate this, everyone. How do you differentiate? Chain rule, huh? 1 by 3, that is 100 plus X square whole power half. So that will be half 100 plus X square half minus 1, so minus half, and then differentiate whatever is inside. That will be 2x. And this will be minus 1 by 5. I skipped some steps to check it out. So 2 will cancel. This will be x by 3 into 100 plus x square power half is 1 by 5. Square on both sides, x square by 9. 100 plus x square is 1 by 25. 25x square is 900 plus 9x square. X is equal to 900 by 16 root 30 by 4, 7.5 kilometers. Okay, with this. So at x is equal to 7.5, we get minimum. No need to do double differential. I asked you minimum and I got only one value, so it is minimum. That much you can take that liberty. So put x is equal to 7.5 in this equation here. So that will be root over 100 plus 15 by 2, na? 225 by 4 by 3 plus 2.5 by 3. That will be 625 by 4, 25 by 6 plus 5 by 2.5 by 5 tha. That is half. How much is this? 28 by 6, 14 by 3 hours. Check. 14 by 3, 4.66. Ronak, that is right. So if you put x is equal to 7.5, you get a minimum time. Have a look at the steps. So main thing is getting this equation. So you need to understand how to start the problem. How does the man go? We don't know. That is how the problem starts. We don't know how he's going. So let him go somewhere between B to C and let that be X. So you get different times for different positions of D. So you get D in terms of X and finish it off. Check. Ask me if you're confused. All clear with this? Let's see one more like this. Can I turn the page? Ritu, your cam is still blank, right? Vidyut, you have become completely dark. Palak, you're still in fog. Turning the page. Next one. Any doubts, please stop me, ask me, get it cleared, and make sure to try all these problems again. Next exam, calculus, you will have this kind of stuff. Next week, you don't have an exam. I think after 2 weeks, you have after this vectors, you have a break. And then you have an exam after 2 weeks. Next one. I'll send you a sheet like this, maximus, minimus, and today. Next one, we have 2 particles. We have A here, which is going with speed u, but the distance is 2d, 0. We have a B here. This guy is also going with speed u, but it is 0, d. So A travels along x-axis. And B travels along y-axis with same speed as shown. Do you think they'll meet? Will A and B meet?
No.
Suppose if they want to meet, where can they meet? This is the only point where they can meet, right? But will they come there at the same time?
No, sir.
So when B comes here, A is only till here. When A comes here, B is already gone ahead, right? Hope everyone agrees, A and B will never meet. So the question is, find the minimum distance between A and B. If they're not going to meet, what is the minimum distance between A and B? I hope the question was clear. They don't meet. So if they meet, minimum distance is 0. The answer will take care of it. How do you do this? Because as they're getting closer now, this will be the distance. This will be the distance. Then while going away, this will be the distance, and this will be the distance, and this will be the this will be the distance. This will be the distance, and again it will increase. So somewhere here, the distance will decrease and then start increasing again. Okay. I hope the question was clear. Clear now, Aryan? Anyone confused with the question, please ask. Try. Okay. Did you use relative velocity, Aditya? No, you solved it. Okay. D root 5 or D by root 5, right? D root 5 to hoga hi nahi na. This is even better than D root 5, isn't it? When B has come here and A is here, this is D. That is smaller than D root 5. Did you just find the initial distance? Is it d by root 5? Check once again. D root 5 तो नहीं है answer. That is wrong. Ritu, question is clear? Maulika? Clear, na? Mayuka, got this? Swastika, Yasha, clear? Vidyut, Smehan? Palak, everything clear so far? Shreyash, Rohan, Ronak? Okay. Try. I'll give you one more minute. Right, Aditya. After doing that, उसको differentiate करना पड़ेगा ना? How do you do this thing? D not Monica. Let's see. So first thing, let the time be t. Let the minimum distance or let's say after time t. Let's just see the scenario. After time t, if you look at the coordinates, what will happen? The B would have traveled somewhere here. This will be 0, d minus ut. Agreed? This guy must have traveled ut ka distance. Similarly, this also must have traveled ut ka distance. So the A ka coordinates will be 2d minus ut, 0. So the distance AB will be this line. So AB square will be 2d minus ut whole square plus d minus ut whole square. This is the distance between A and B as a function of time. Make sense? So for minimum distance, we no need to differentiate the whole thing. This has to be minimized. If you want minimum distance, then that function itself should be minimum, right? So just differentiate that function. Therefore, d by dt of this function 2d minus ut whole square plus d minus ut whole square is 0. You can differentiate that root thing also. It doesn't matter. But why to differentiate a root? Just differentiate what is ever inside. You can simply say if AB square is minimum, then AB is minimum. So if I differentiate this, you end up with, remember chain rule. Remember here t is a variable, d is constant here. 2 times 2d minus ut, and then differentiate whatever is inside. I am writing it in more detail. This will be 2 into d minus ut, and then differentiate whatever is inside. Simplify this. So 2 into 2d minus ut, and this guy will be 0 minus u. 2 into d minus ut, 0 minus u is equal to 0. Simplify this, you end up with 2d minus ut plus d minus ut is equal to 0, t is equal to 3d by u. Check. So at this time, you get a minimum distance. So therefore, AB minimum will be substitute t there. So root over 2d. So ut ka value is 3d basically. 2d minus 3d whole square plus d minus 3d whole square. That would be we goofed up somewhere. Did I mess up somewhere? थ्री डी बाई टू यू था वो. That will be d by 2 whole square, d square by 4 plus d square by 4 ka root, which is d by root 2. That's your answer. D by root 2. Time is 3d by 2u. So the minimum distance is d by root 2. And you know, where does this occur? If you look at the time here, when time is 3d by 2u, the b has gone from here to this point actually. B has gone to 0 comma minus d by 2, and the a has come here, d by 2 comma 0. This was the minimum distance. This position gives you the minimum distance. Please check the steps. So what I did after time t, I found the positions, new positions. B must have traveled ut downward, A must have traveled ut on the left. So the coordinates become 2d minus ut for A and d minus ut for the y coordinate of B. Then I use the distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. Then I got the distance. Then I differentiated it. And then I put it back down. Once you got this, question is over. It is just maximum minimum. Check. Now you can go d by root 5. Who got this? Anyone got this? No one got this. Have a look at this. Let's see one more. Let's see a little different type of questions. We have seen motion now. We will see another variety. Clear? Can I turn the page? Niranjan, clear, na? Abhinav, Aryan, clear? Rehan, clear? Ronak, all clear?
Yes, sir.
Great. Next one. Everyone should type your answers if you got it. Don't hesitate. Type, even if it is wrong, that's okay. 19th one. Let's say we have a fence of length 100 meters. So someone gave you a big fence of length 100 meters to construct a rectangular enclosure. So let's say you have a lot of sheep in your farm and you want to construct a enclosure. Matlab, you don't want the sheep to escape. But luckily in your farm, you have a small hill also. So rectangular enclosure with 3 sides. Where at the 4th side is blocked by a hill. So there's no need to construct all the 4 sides. You can save some, you can save some fence. But you have to use all the 100 meters. 4th side with the hill. So let's say we got some hill like this. And you're constructing fence like this. We're getting only 3 sides. And inside we have a sheep here. Yeah, they look cute. Okay. So no need to construct all the 4 sides. If you construct 3 sides, your job is done because the 4th side will be blocked by this thing, the hill. And this is that rectangular thing. Now the question is, you can construct however you want. See, you can construct it like this. You can construct it like this. You can construct like this. You can construct like this. You can keep any length and any breadth. So find the maximum possible area of the enclosure. So the total length of the fence is 100 meters. So how should you construct the fence? Means for a rectangle, how will you take the length and breadth as? And directly that is the question. Nahare Ronak. I know you will say that. Some people mug up the answer 625. That's wrong. You know what is the question for that? A man has 100 meters of fence. Find the maximum area of enclosure if he constructs a rectangle. That means you have to construct all the 4 sides. Because for a given rectangle, among all the rectangles for a given perimeter, square has the maximum area. Remember? Rehan, you are right. Others try. I'll give you a minute. So now we got into maximizing areas and stuff. Till now we are finding minimum distances. So questions will be framed like that: minimum distance, maximum area, maximum position. We'll encounter a lot of stuff like that. Aditya, you got it right. Try others. Adrit, you got it right. Ronak, you are right. See. So how do you start this? So you just need to make a rectangle with 3 sides. No? Let the length be L, let the breadth be B, and let the breadth be B. Third side you need to construct. So what is given here is the length of the fence is nothing but perimeter. The length of the fence is L plus 2B, which is equal to 100. The area of the fence, even though the fourth side is not there, it's still L into B. So A is equal to L, B will be 100. So L will be 100 minus 2B into B. So we got area is 100B minus 2B square. So simply the question is maximize area. So see, whenever you get questions like this, right, if there are 2 variables, somehow you have to eliminate one variable, either L or B. So how to maximize area? dA by dB. That will be 100 minus 4B is equal to 0. So when B is equal to 25 meters, you get a maximum area. That means length is 50 meters. So therefore the maximum area is 50 into 25, 1250. If you had actually constructed a full fence, you would have got 625. Just eliminating one side, the area doubles. Check. Have a look at the steps. Did you see the calculus is actually easy? Once you got the equation, calculus is pretty easy. Just differentiate and equal to 0. The headache is to get that equation. Check it out. Let me ask you one more like this. Any doubts on this, please ask. Next one. Next one. So I gave you a wire. A wire of length L is used to construct a sector. You know what's a sector? It's like a slice. So basically like this. Part of a circle. Now, how can you construct this? You can make a big sector like this. You can make a long sector like this. You can make different sectors, right? But the total length of the wire is only L. Find max area of the sector. This is kind of like previous problem, but only change the shape. You have a wire of length L. You have to bend it and make it a arc plus two sides, two lengths. So you can bend it however you want. You can make a broad one, thin one, anything. What is the maximum possible area of the sector? So currently in PS, which chapter are they doing there?
Kinematics.
They started
Kinematics.
The calculus.
The integration they did
Okay.
Yeah, we just started today.
Kinematics abhi start hua.
No, we started integration today.
So some one-dimensional kinematics he did like previously.
Okay. Ask them for the test schedule, right? The major test ka test schedule. If you got something, send it to me.
Yes, we got.
Got it? Na? You sent it to me now already.
Yeah.
Can you just post it again in the group? I think I lost it. Post it in the group later on. I will just check it out.
Sir, we have started kinematics.
Recently, no?
Yes, sir.
Yeah, chalega. Even we bumped up the class. We'll catch up. How to do this? Answer will come in terms of L. Obviously. For people who don't know, let me give you a small thing. If you know, if you have a full circle, right? This angle is 360 degrees or 2 pi. So area was pi r square. So if you just have a sector like this with theta, the area of a sector is theta r square by 2. That result you need. So the area of a sector, right? This thing is theta r square by 2. If theta is equal to 2 pi, you get a full circle. So in case someone don't know area of a sector, that's how you get that result. Now try. Maybe you don't know that part. So we have a sector of radius r and theta. The area will be theta r square by 2. You actually get it from unitary method. For 2 pi, area is pi r square. For theta, what is the area? Theta into pi r square by 2 pi. Unitary methods, you get the area of a sector. You can leave it there. Try. I'll give you a minute more. L square by into LR/2 क्या रेहान? R तो दिया नहीं. R तो you don't know. How do you start? See everyone. Let the sector be radius R, angle theta. So if that is R, this is R. This arc length will be R theta. Agreed? Towards the total perimeter. Perimeter will be 2R, the two radiuses plus R theta. What is the area? Area A will be theta R square by 2. See, this is what I was saying. See, the area will depend on two variables. Theta is also changing, R is also changing. I can't do that. I need only one variable. So let's get theta here. So L minus 2R by R. So area will be L minus 2R R square by 2. So you have to convert out of two variables, theta and R, which both are variable, eliminate one of them. You need to get the function only in one variable. You can't differentiate theta and R at the same time. That is a catch in all these problems. So they will, so this is how it is. In the question, you will have two variables, let's call it X and Y. There will be some relation between them, and they'll ask you a quantity depending on these two things only. You have to eliminate one variable. So this guy will be LR square by 2 minus R cube. So this is the area as function of only radius. Theta got eliminated. You can ask me, sir, why are you not eliminating R? I can do that, but if I eliminate R here, there's a square function that looks messy. You would have got the answer. I just try to keep it simple. So dA by dr is 0. So that will be L is constant here. This will be 2R minus 3R square. 2 cancels off. L by 3 is R. Did I goof up somewhere?
Then theta L minus 2 R.
एक और R है ना यहाँ पे. I goofed up. There's an R in the denominator. So this would be L by 2 minus 2R is equal to 0. So we get R is equal to L by 4. You're done. So what is area? LR by 2 minus R square. So put L by 4 here. L by 2 into L by 4 minus L square by 16 is L square by 16. Check. Maximum area is L square by 16. Like I said, physics, we are more interested in applications. The actual differentiation, we are least bothered. If you see, all these differentiations are simply square for x power n differentials.
Instead of R, we can isolate theta as well, right?
You could have done that. You would have got the same answer.
I did not get the answer. That's
You must have goofed up. क्या गया था? If you eliminated theta by 2 into R को करना है तो L by 2 plus theta का whole. That will become too complex, right? Na?
Sir, I wrote the equation as L is equal to 2 pi into theta by 360. Then
L
R
is equal to?
becomes
No, L is equal to?
2 pi r into theta by 360.
2 pi R into theta by 360. Why did you do that? You should keep angles in radians, right? God. 360 right in terms of pi, na?
ठीक है.
SI units. And you have to add these two R's also, na? Side mein. No, sector is made of two sides and one arc. All got this? Next one. Let's see one more like this, but a little different. We have a metal sheet of area 100 meters square to construct an open top cylindrical tank. Open top cylindrical water tank. Meaning you want to construct a cylinder tank like this. Bottom is closed, bottom is closed. The top is open. Now, how can you construct the tank? You can make a tank like this broad tank, but the height will be small. Or you can construct a long tank, right? You're getting it? You can construct different types of tanks. So we are assuming you're using this sheet of area 100 meters square. Find the maximum volume of the water tank, assuming there is no wastage of sheet. So construct a water tank such that has a maximum volume. Max volume of water tank. Assume the entire sheet is used somehow. Get this. So now from, if you see rectangle and sector was actually lines, so we got into 3D structure now. From 2D to 3D structure we jump. How do you do this? So here what remains same? The surface area. Remember the tank is not fully closed. Upper is empty. So just to give an idea, the tank is made of one hollow cylinder like this, and niche you have a disc also. So you have to make one disc at the bottom and you have to make one hollow cylinder also. That is your water tank filled with liquid. If you had closed it to, there would have been two discs. That is the only difference. Try. Everyone should give it a try. Ritu, your cam is still gone, right? It's still dark. Do something about it next time. Ronak, Shreyash, make sure to do something about your cams next time. Vectors ka test will be online.
Now.
Ritu. I can see you now, Ritu. Hello. You got stuck, I guess. Ritu, you're saying something. I can see you now. Clear. Venkatesh, next time do something about your cam. Huh? When you guys are writing, make sure I can still see your face. Keep this in mind. In the class, the cam should be, I should be able to see your full face even when you're writing. Someone might just keep their head down and sleep. Not accepted. You are eating secretly some good food, not allowed. 44 by 7 meter cube. I don't think we get a beautiful answer, right? Ronak, you got
Very
something.
long calculation.
I know, answer is a little bad, but can
I just type the value of R there?
चलेगा. Root में आएगा answer, but let's see everyone how to do this thing. So let the radius be R. So the first important question, right? Whenever you get a question, first you have to create variables. How do I assume variables? So this is R and this is H. Obviously, for a cylinder, what else will be there, right? The radius of a cylinder and the height of a cylinder. So you don't know the radius, you don't know the height. Both are not given. Surface area. The curved surface is 2 pi RH plus the base area is pi R square. This is the curved surface. You should know this. This is the bottom disk. This you know. Now, for people who don't know that curved surface, let me show you how that looks. If you take a cylinder like this, of radius r and height h, and if you take a scissor and if you cut it here, and if you open this, you get a rectangle whose base will be 2 pi r and the height will be h. That is because this circumference will be this. So this area is length into breadth, which is 2 pi r h. I hope now you got this in case you don't know. Yasha, that looks right. So that is your surface area. So you have this outer cylinder and the base. What is the volume of a cylinder? Volume of a cylinder is a base area pi r square into h. So again, there are two variables here, and this is 100. I don't want two variables. I need to eliminate one of them. H is the best one to eliminate because there's an r square here that gets messy. So h will be 100 minus pi r square by 2 pi r. The volume will be pi r square h. Substitute that h here. That will be pi r square into 100 minus pi r square by 2 pi r. Pi r goes off. This would be 50 r minus pi gaya na, pi r cube by 2. That looks right. Yeah, that looks right. So this is the volume. So we have to do maximum minima. So dV by dr equal to 0. That would be 50 minus 3 pi r square by 2 is 0. This gives you r is equal to root over 100 by 3 pi. So if the radius is root over 100 by 3 pi, you get a maximum volume. So maximum volume will be, jo r ka value you got, take it and put it back in this. That would be 50 into r 100 by 3 pi minus pi r cube by 2. 100 by 3 pi will come out and you'll still be stuck out with 100 by 3 pi. I'm scribbling now. 100 jayega. That is 50 by 3. 50 minus 50 by 3. 100 by 3 root over 100 by 3 pi meter cube. That's your answer. I scribbled it here. Actually, let me write that properly. This would be pi by 2. R cube will be 100 by 3 pi whole to the power of 3 by 2. Now you can take out 100 by 3 pi out. And 100 by 3 pi will be stuck inside. Pi will cancel. 2 za 50 za 50 minus 50 by 3. That will be 100 by 3 root 100 by 3 pi. Check. Yasha, that is right. No, you got too small, I guess. Somewhere you messed up. Check everyone. Have a look at this. Any doubt on this? Anywhere you're confused? There. That's how you actually use differentiation. The main thing is this. This is how we get applications. We will be seeing a lot more later on as chapters come. But for now, you should have this much idea there. I'll be sending a sheet on this. So there is something called rate of change. It is not a big thing. Next class, I'll be showing you that 1-2 problems we'll do, and then we'll start off with integration in the next class. So differentiation, major thing is done. So this much differentiation, what I taught you, is required for 11th and 12th physics. In your classes, they must have taught you by more weird differentiations. E power something, A power something, all that is nonsense. Physics, when you never see that. But I'm sure they didn't do applications, maybe. If they did, so fine. If they didn't do, you learned it now.
Yes, sir, we did.
Okay. All clear with this? Yeah. So with that, we'll wrap up with this. So we will see paper cut outs and that vectors ka assignment, which is sent you the second one. So if you have no doubt, you're free to leave. So first thing,